Continuing the discussion on different types of measurement validity, in this lecture, we're going to talk about convergent and discriminant validity. So the first is convergent validity. Convergent validity is quite simply the degree to which operationalizations of constructs that are similar converge on each other. And what convergence means is that constructs that are related are strongly correlated, right? Correlation ranges from -1 to +1. The closer you are to 1, the more perfect the synchronicity, more perfect the relationship between the two items or constructs. So if we take, let's say, a construct self-esteem, and just for this example, if we assume that it has 4 items, what that means is it has 4 statements that measure, or 4 questions that all together measure self-esteem. The convergent principle would suggest that all 4 items would correlate very strongly with each other. So here is a correlation matrix. In a correlation matrix, what you're looking at here is the correlation of each item with every other item. So if you look at the top row, the first row, correlation of item number 1 with itself is 1, item number 2 with 1 is 0.83, 3 with 1 is 0.89, 4 with 1 is 0.91. The second row, correlation of item number 1 with item number 2, 0.83, item number 2 with itself, item number 3 with item number 2, which is 0.85, and item number 4 with item number 2, which is 0.90. So notice that all the correlations, the 0.83, 0.89, 0.91, 0.85, and 0.90, are very high, providing evidence that the items are all converging on the same construct. Then this would suggest that we have convergent validity. Another form of validity is called discriminant validity. Discriminant validity is the same principle but on the opposite, which is the degree to which operationalizations are not similar should diverge. In other words, they should not be synchronous, right? So in other words, the correlation should not be high, or they should, in contrast, be low. So if there are measures of different constructs, those items should not correlate with measures of another construct. So if you recall, earlier we were talking about a 10-item measure for a test anxiety called the West Side Test Anxiety Scale. So if we look at, let's say, 2 items from this, we would argue that the 2 items for test anxiety, TAS1 and TAS2, should not converge with, let's say, 2 items of the self-esteem construct SE1, SE2, right? That would suggest that we have discriminant validity. So discriminant validity would look something like this. The correlation between SE1, which is the first item for self-esteem, and the first item for the test anxiety construct is 0.12. The second construct, SE1's correlation with the second item in test anxiety is 0.01. SE2's correlation with the first item in test anxiety is 0.04. SE2's correlation with the second item in test anxiety is 0.11. So this is, again, just made up numbers, but really what it tells us when we have such low correlations, correlation ranging from -1 to +1, the closer to 1, the more highly correlated, the closer to 0, the more low the correlation. This gives us evidence of discriminant validity. Now, generally, when we put it all together, convergent and discriminant validity, we actually put them in a matrix together, what is called as a multi-trait, multi-method matrix. We would basically take, in this example that we have, let's say 3 items from self-esteem, 3 items from test anxiety, and put them all together in one giant matrix. And if you look at the upper left where it's green in color, that's the correlation between self-esteem and all its items. In the bottom right, the items in red are the correlation between test anxiety, the 3 items, and each other. And there you can see evidence of convergence. All the correlations are high. And then you see divergence in the cross correlations, in the multi-trait correlations. In other words, self-esteem's correlation with test anxiety, and then test anxiety's correlations with self-esteem. And so they tell us that there is convergent and discriminant validity.